there! If you've had experience programming in another language before, what we're about to tackle right now may already be familiar to you. But stick around if you want to better familiarize yourself with Python syntax. Since we're just starting, why don't we go ahead and get into the basic concepts first? My name is Janica, and today I will share with you some basic programming concepts as well as help you create your Hello World program and dabble a little bit with arithmetic operations in Python. In the last module, I mentioned PEP 8. PEP 8 is the style guide for Python that specifies the best coding practices, including, but not limited to, indentations, comments, and naming conventions. The IDE we've installed in the last module, PyCharm, has the ability to guide you through the best practices while coding, but for starters, here are some of the most important things to observe when coding in Python.
The first two are general programming best practices. But first, make sure to leave descriptive comments for your code. Don't leave others in the dark. Use comments to summarize what your code does to make it easier to understand for others. For block comments, use 3 quotation marks at the beginning and at the end of the block of text. This is an example of a block comment. Easy, right? For single-line comments, you just need to use the hash sign at the beginning of the text. This is an example of a single-line comment. You need to put another hash sign for each line of comment. Second, use sensible names for your variables and functions. Avoid naming them as ABC, XYZ, FOO, and BAR. Using random words and letters will definitely confuse other people, and most likely you, yourself, in the long run. Third, use snake underscore case as your naming convention. Snake underscore case is basically lowercase naming with underscore serving as its separator instead of a space. And last, be wary of your indentation, especially with functions. Python functions don't come with brackets after all. You'll learn more about this in an upcoming module.
So now that you know some of the best practices, we're going to begin coding. Let's open PyCharm Edu, the IDE we've installed in the previous module. If you prefer using any other IDE, that's fine. Just make sure you have Python configured in your chosen IDE.
Now to begin. If you're launching the IDE for the very first time, click on Learner. After this, click on New Project. Then change the highlighted text Python Project on the location field with My First Python Code. Leave everything else unchecked and click on Create. What you'll see upon loading is a sample script generated by PyCharm. To run this, simply click on the green button. It should print, "Hi, PyCharm." Now, just like any other programming language, Python has built-in functions both to ask for user input and to display output. For user input, we use input, open parenthesis, close parenthesis. And for output, as you can see on line 9, we use print, open parenthesis, close parenthesis. To display any output, simply enclose the desired output with the open and close parenthesis of the print function. Now, to let you try it by yourself, let's create your own Python script. To create a new script, just right-click on the folder named My First Python Code. Hover over New, and then click on Python File. For the name, simply type hello, then hit enter to create a new file named hello.py. Let's now try using the print function by creating your first Hello World program in Python. Simply type in print, open parenthesis, quotation mark, hello world, exclamation point, quotation mark, close parenthesis. Don't forget the quotation marks. You need the quotation marks for strings, meaning an output composed of characters like this one. Now, once you're done, let's save this by doing Ctrl+S on Windows or Command+S on Mac. After that, click on the green button to run the code. And that's it! You've successfully created your Hello World program. But how about the input function? We need to try that too. Now let's spice things up a bit by asking for a name to greet someone hello. Let's delete the Hello World line of code we've created with something else. Let's type in name equals input, open parenthesis, quotation mark, please enter a name, colon, quotation mark, close parenthesis. Print, open parenthesis, quotation mark, hello, quotation mark, plus, name, plus, quotation mark, exclamation point, quotation mark, close parenthesis. But wait, what's that thing before the input function, you may ask? That's called a variable. After asking for the user's name, we need to remember that we're using a variable called name to store that value for future usage. On the print function, you'll notice the way I'm printing the name variable along with the hello greeting. What the plus sign does is it concatenates or it combines the variable together with the hello and the exclamation point. Once you're done, let's save this by doing Ctrl+S on Windows or Command+S on Mac. After that, click on the green button to run the code, and on the console below, type in any name you want, then hit Enter. Isn't it great? Not only have you tried these two very important built-in functions, but you've also created and used your very first Python variable.
Speaking of Python variables, it's important to know that there are multiple data types available in Python, so you need to be mindful of this, especially when using variables. The standard Python data types include Boolean, numerics, strings, lists, tuples, sets, and dictionaries. We'll be tackling everything in the modules to come, but for now, we're going to concentrate on Booleans, numerics, and strings.
Boolean, just like the logical truth table, is a matter of true or false. The naming convention should always be capitalized when it comes to Boolean values. If we're going to run this code, using the type function, we're able to verify that the answer variable indeed contains a Boolean value. Answer equals true. Print, open parenthesis, type, open parenthesis, answer, close parenthesis, close parenthesis. You'll encounter Boolean values a lot in the upcoming modules, particularly for logical operations and loops, so stay tuned. Now, just like what I've mentioned while talking about the print function, you need quotation marks for strings. A string is a sequence of characters. Therefore, if we're going to run this code, using the type function, we're able to verify that the greeting variable indeed contains a string type value. But what about numerics? Numbers in Python could either be a float or an integer. When we say integers, these are signed whole numbers. For example, if we're going to run this code using the type function, we're able to verify that the sum variable indeed contains an integer type value. Float, on the other hand, are floating point numbers. This means that the number has a decimal point as opposed to integers. For example, if we're going to run this code using the type function, we're able to verify that the sum variable indeed contains a float typed value.
Hate it or not, we can't talk about numbers though without dealing with math at some point. So why don't we try doing some arithmetic operations in Python while we're at it? There are 7 arithmetic operators in Python: addition, subtraction, multiplication, division, modulus, exponentiation, and floor division. You can use these operators interchangeably to form an arithmetic expression. It's also important to note that Python arithmetic expressions follow the PEMDAS rule. Therefore, you could also make use of the parentheses to specify the precedence. What we have here in code are sample arithmetic expressions.
If you'll notice, Python followed PEMDAS by executing 5 divided by 3 first before adding 10 to the quotient. By using parentheses, however, we can easily change the order of calculation of the expression. Notice how this time 10 was added to 5 first before getting divided by 3, resulting to a new output. We could also do floor division to get a quotient without any remainder. See how the trailing 0.6666666 disappeared? Lastly, you could make use of the modulus operator to see if a dividend in a divisor has a remainder or not. This is useful when determining odd, even, or divisible numbers. The output for this is 0, since 15 is divisible by 3. However, if we change this to another number that isn't divisible by 3, then it returns the remainder.
Amazing, isn't it? Python also comes with other built-in mathematical functions, which can be used for complex equations such as trigonometry and logarithms. Feel free to explore and use these to your liking. So, for this module, we learned some basic programming concepts, such as some best coding practices, the print and input function, variables, and data types. We were also able to create our Hello World program and explore basic arithmetic operations in Python. In our next module, we'll be talking more about logical expressions and control flow statements. Thanks for listening and see you on the next one.